So we are addressing the automotive turbocharger market, which is driven by decreasing emissions and reaching higher performance. In the race to achieve maximum efficiency, ball bearings have been proven to play a key role. But ball bearings require a good understanding of clearance propagation under temperature. Therefore, accurate thermal mapping of these components is necessary to accelerate turbocharger development. In this study, 3 companies were involved. That's IHI, which provided the test samples as well as the testing facilities. Minebea, which is the bearing manufacturer and assembled the bearings. And Sensor Coating Systems, short SCS, conducted the temperature measurements and analysis with the thermal history paint technology. For the first time, thermal history paints have been successfully used to map temperatures across turbocharger bearings in engine gas stand tests. By correlating the temperature maps with expected thermal expansion, clearance can be set more precisely during turbocharger assembly. This improves performance and prevents premature failure. Detailed thermal maps generated by thermal history paints mean that turbochargers can be more confidently assembled. This significantly reduces development costs and time, thereby accelerating the rollout of higher efficiency engines, ultimately driving down carbon emissions.